Hi, welcome back to Fan Stories. What if I told you we might soon be able to breathe on the moon?
Oh, sure. Let me just pack my moon tent and space barbecue grill.
No, seriously. A China lab just figured out a way to turn sunlight into oxygen using nothing but moon dirt.
Wait, what? That's not science fiction?
Nope, it's cutting-edge tech. And they published it quietly in an app called Weibo on June 18th, 2025.
So, China's building air on the moon, and we're just sitting here?
Today, we're diving into a wild question. Can we really make oxygen on the moon? And if the answer is yes, does that mean we're one step closer to living up there? If we ever want to build a base on the moon, we need oxygen. To breathe, of course, but also to make rocket fuel. One of the most efficient fuels is liquid oxygen plus liquid hydrogen. If you can produce that on the moon, you don't have to carry it from Earth. But there's a problem. The moon has no atmosphere, no oceans, no forests. So where do you get oxygen?
That's right. So, how are they planning to fix that?
Exactly. And that's why scientists had to look for oxygen in the ground. Believe it or not, moon dust is full of oxygen.
That dusty stuff astronauts kick around?
Yup. Moon soil, called regolith, contains compounds like silicon dioxide, aluminum oxide, and magnesium oxide. All of those have oxygen atoms bound inside.
So, you're telling me the moon is like a giant locked up oxygen tank?
Exactly. The problem is it's chemically locked. You can't just breathe it in.
So, how do we break it out?
Through high temperature electrolysis. Basically cooking the regolith at over 1000 degrees Celsius, and then using electricity to rip the oxygen free.
Okay, that's kind of awesome, but also sounds dangerous.
Well, it's science. If it doesn't scare you a little, it's not working. Now here's where it gets clever. Unlike Earth, the moon has no atmosphere to filter sunlight.
So, full exposure, no sunscreen. You're toast.
Exactly. But for machines, it's perfect. You get ultraviolet, visible, and infrared light, all without any loss.
Wait, but regular solar panels don't use all that, right?
Right. Most panels on Earth only use visible light efficiently. They actually waste a ton of heat and ultraviolet.
So this new system uses the whole thing?
Yes. It's called full spectrum solar utilization. They're not just harvesting light, they're dividing it into zones. Short wave for one reaction, long wave for another. It's like a solar buffet.
Now that's what I call a light diet plan.
Now we get to the juicy part. They created a system called PVPETE, photovoltaic, photo-enhanced thermionic emission. What it does is brilliant. Part of the light makes electricity like normal solar panels, but the rest, the heat, is used to kickstart chemical reactions. You're using the light and the heat at the same time.
Nothing wasted?
Exactly. Plus, it works even at super high temperatures, making it ideal for lunar conditions.
I can't even cook eggs in my kitchen without burning something. These guys are making oxygen with lasers?
Close enough. Here's the really wild part. They're basically building machine-based photosynthesis. They combine sunlight plus CO2, or H2O, into O2 plus fuel. Same as plants, but in a steel box. They tested how different wavelengths affect the reaction, UV, red, IR, and adjusted the material layers accordingly.
That's more attention than my plants ever got.
And unlike plants, these machines don't die if you forget to water them.
Okay, but what's the efficiency?
They reported over 90% light-to-reaction efficiency.
90? Nature is shaking right now.
All of this is part of a bigger concept called ISRU, In Situ Resource Utilization.
That sounds expensive.
It actually saves money. Imagine launching a moon base. Every kilogram from Earth costs tens of thousands of dollars. So instead, use what's already there. Moon dust? Use it to build bricks. Frozen water? Use it for drinking and fuel. And oxygen? Use regolith plus solar equals boom, free air.
ISRU sounds like survival mode, but smarter.
It's literally how we'll build permanent space habitats.
Okay, but is anyone else doing this?
Good question. NASA is working on something similar with their Artemis mission. And this time, they don't just want to plant a flag and go home. They're aiming for a sustainable presence, like living off the land, Lunar ISRU style.
So they want to build a moon base that makes its own oxygen, water, and maybe even fuel?
Yup. If they succeed, we're looking at a future where the moon becomes humanity's gas station for the solar system.
So why is this China lab special?
Because they're the first to integrate full-spectrum sunlight, advanced modeling, and material optimization into one working system.
And they just published it quietly?
In the University of Science and Technology of China Journal. No press conference, no PR team, just boom, oxygen on the moon.
They really went, we don't need applause, we need results.
Exactly.
Okay, real talk. When can we start moving in?
Well, if this tech scales, we could deploy automated units to the moon in the next 10 to 15 years.
Like solar trees that just sit there making air?
Yes, modular units that combine solar capture plus oxygen production. You set them up, let them run. They prep the site before humans even arrive.
So we'd land and the air's already made.
That's the dream.
Okay, but what would living on the moon actually be like?
Probably a bit like camping, in a freezer, with no atmosphere.
So, like Iceland, but more deadly?
Exactly. You live in airtight habitats, powered by solar energy. Your air, water, even plastic could be made on-site from local materials.
Plastic? From moon dirt?
Not directly, but once you have water and CO2, you can synthesize polymers. Some plans even include 3D printing furniture and tools using moon dust mixed with binders.
So, IKEA, but space edition.
Flat-packed oxygen included.
The moon has crazy temperature swings, right?
Yeah, over 100 degrees Celsius during the day and minus 170 degrees Celsius at night.
That's like going from a sauna to Antarctica every day?
Pretty much. That's why these oxygen systems are built with thermal insulation, heat recycling, and dust shielding. The PVP units especially are designed to thrive in extreme heat.
What about radiation?
Good question. The moon has no magnetic field, so cosmic rays and solar storms are real threats. Most systems are designed to bury parts underground or shield with regolith walls.
So we fight the moon, using the moon.
Poetic, isn't it?
What if the oxygen machine fails?
There would definitely be backup oxygen tanks, just like on the ISS. But these systems are being designed to be fully autonomous, with multiple fail-safes and self-diagnostics.
Can astronauts fix them?
Sure, but ideally, robots fix robots. Imagine little maintenance bots checking valves and replacing filters.
So it's like living in a smart home, where the house literally keeps you alive.
Yeah, and if something goes wrong, the system doesn't just fail silently. It sends alerts, reboots, and even reroutes energy where needed.
Okay, that's kind of next level.
If you're gonna trust your life to a machine on the moon, it better be smarter than a smart fridge.
And the next step? Mars?
Definitely. If this works on the moon, the same principle could be used on Martian soil, which also has oxygen in mineral form.
Please let them invent Martian pizza ovens too.
Priorities. Here's a fun fact. If you wanted to send 1 ton of oxygen to the moon right now, it would cost you tens of millions of dollars.
Just air? Just oxygen?
Yep. Launching stuff into space is crazy expensive because every extra kilogram means more fuel, bigger rockets, and more money.
What if we use SpaceX's Starship? That's supposed to be cheap, right?
Cheaper, yes, but cheap in space terms is still hundreds of dollars per kilogram, even in the best case scenario. And that's only the launch cost. You still have to land it on the moon safely. That's why making oxygen where you need it, on the moon, becomes not just smart, but necessary.
So, if this works really well, could we actually sell moon oxygen?
Funny you ask. Yes, oxygen could become a space commodity. Not for Earth, but for fueling rockets heading deeper into space.
Like a moon gas station?
Exactly. Rockets could launch from Earth, refuel at the moon using locally made liquid oxygen, and then continue to Mars or beyond.
That's actually brilliant.
It's the foundation of a space economy, where resources are produced and traded in space, without always going back to Earth.
So one day we might see "Made on the Moon" stamped on oxygen tanks.
And that would mean humanity has truly started living beyond our home planet. So, what do you think? Would you trust your oxygen supply to a machine on the moon?
Or do you want to stay on Earth, where trees still do the job?
Let us know in the comments. And if you want us to dive into how Mars colonization might work, hit like, and we'll go interplanetary next time.
Also, if anyone's selling moon-made air in a can, I want one.
Breathe responsibly.